The way network communication goes in and out of a machine physically is through the NIC, Network Interface Card. The way network communication goes in and out of a machine logically, though, is through a program or service. A service is a program that runs in the background, independent of a logon that provides functionalities to a system. Windows client machines, for instance, will have a workstation service running in the background that allows for connections to remote network resources. It's not tied to a single user logon and is always running in the background. When you start a web server, you're starting a specific server service that isn't tied to a specific user logon either. This way, when the server reboots, the service automatically starts before anyone logs on. In the world of Linux, services are known as daemons. Well, how does network communication go in and out of a program or service? Let's say a single machine is running both an FTP, File Transfer Protocol server, as well as a web server. If they both are accessible by the same IP address, how does the traffic for the FTP server get to the FTP server, and the traffic for the web server get to the web server? Think about an apartment building with a mailbox grid in the lobby. The man in apartment 21 checks his mail with a key to box 21, and the woman in apartment 80 checks her mail with a key to box 80. The mailman brought their mail to the same building. They both live in the same building with the same street address. This is like two different servers that are accessible through the same IP address. However, when traffic is destined for the man in apartment 21, it is noted on the front of the envelope. And the same goes for mail addressed for the woman in apartment 80. Similarly, the way into and out of a program or service is through a port, which is a logical number. So, in addition to source and destination MAC addresses and source and destination IP addresses, there are in fact source and destination ports. MAC addresses are found in frames at layer 2 of the OSI model. IP addresses are found in packets at layer 3. Port numbers are found in either TCP segments or UDP datagrams at layer 4. Based on the destination port, the destination machine knows which program or service to send the data to, the same way that the mailman knows to put the mail for apartment 21 in the box for apartment 21, and the mail for apartment 80 in the box for apartment 80. Ports are organized into 3 categories. Well-known ports from 0 to 1023 are used by major protocols and services. For instance, FTP servers listen on port 21, and web servers listen on port 80. Registered ports from 1024 to 49151 are assigned by IANA, the Internet Assigned Numbers Authority, for specific companies that want a common port to be used for their programs or protocols. However, these ports can be used by any system if currently not in use. Registered ports are locally significant to a system. It's not like using a registered IP address, which has global scope. Dynamic ports from 49152 to 65535 are used by client applications on an as-needed basis. For example, your browser might open up port 60,000 to send a request to a web server that will be listening for requests on port 80, unencrypted HTTP. The web server's response is sourced from port 80 and is destined for the port that your browser opened up. After the communication between your browser and the web server is complete, your browser closes up the port it opened, but the web server's port remains open for new incoming connections. Your browser will subsequently open up a different port in that dynamic range for traffic to and from the same or a different website.